Alright, so this is section 1.6, geometric sequences. So we've already talked about arithmetic sequences and finding mathematical patterns. Now we're going to talk about geometric sequences, how to find a recursive formula and an explicit formula. So a geometric sequence is a sequence in which the terms are found by multiplying the preceding term by a non-constant 0. The constant r is called the common ratio of the geometric sequence. So looking at the first two examples that we have, it says the following sequences are geometric. So in order to show that they are geometric, we can show that they have the same common ratio between each of the terms. So in order to find the common ratio, you're going to take the term that precedes the first term, and you're going to divide them all. So in this case, you would say that r, your common ratio, would be equal to, and you have to show that 3 over 1 is equal to 9 over 3, which is equal to 27 over 9, which is also equal to 81 over 27. So now if you notice that if you were to simplify each of these, your common ratio, or r, would be equal to a value of 3. And since it's the same for each of them, we know that this is a geometric sequence. And yes, you would have to show that it's the same for all of them. So if you look at the second example, the sequence 64, negative 32, 16, negative 8, and 4, we would do the same thing. So for our r value, or common ratio, we would do negative 32 divided by 64. That would have to be equal to 16 divided by negative 32, which also has to be equal to negative 8 over 16, which also has to be equal to 4 divided by negative 8. And if you notice, if you reduce each of these, they are all equal to the same common ratio, which is negative 1/2. And so since they have a common ratio, we know this is a geometric sequence. So then, because of that, we can go ahead and write this in a recursive formula. So just like the recursive formula for arithmetic sequences, geometric sequence, we have kind of the same thing. So recursive formula for geometric sequence, u sub n, we would write the nth term is equal to your common ratio times the previous terms. And don't forget that you also have to state what your first term is in order to do this, these problems. So if we look at the first example, it says, are the following sequences geometric? If so, what is the common ratio? Write each sequence as a recursive function. So if we look at the first example, it's actually 3, 9, 27, and 81. So this is like the first example that we did, except for it doesn't have 1 as our first term. So in this case, we know that the common ratio, if you do 9 divided by 3, 27 divided by 9, 81 divided by 27, the common ratio, or r, would be equal to a value of 3. So that's our r value. So yes, we know that this is a geometric sequence. So now if I want to write the recursive form for the sequence, I would have to state the first term and then state the rule for finding the nth term as such. So my first term is u sub 1 is equal to 3, and the way to find the nth term in the formula, I would do u sub n is equal to my common ratio r times my previous term, so u sub n minus 1. And of course, this has to be for n greater than or equal to 2. Why is it n greater than or equal to 2? Because we already stated our first term, u sub 1. So then we're trying to find the next term, which would start with 2. So if I, into this formula, u sub n would plug in 2, u to the second then would be equal to 3 times u to the 2 minus 1. And that's what I would be solving. So u to the 2 minus 1 is the same thing as the first term, so this says that we want 3 times our first term, u sub 1, and we know u sub 1 is equal to 3 because that's what we were given when we wrote the recursive formula. So 3 times 3 would then be equal to 9. So then in this case, I would say my second term, u sub 2, is equal to a value of 9. And that's why we have to state n is greater than or equal to 2. So we could do the same thing for the third term, the fourth term, and so on and so forth. So let's go ahead and do the next example. So for this next sequence, we have 5 halves, 5 fourths, 5 eighths, and 5 16ths. So first things first, we would have to find the common ratio and see if it's the same for each of the different terms. So you would have to do 5/4 divided by 5/2, 5/8 divided by 5/4, and 5/16 divided by 5/8, and see if they're all equal. So when we do this, you would see, yes, this is a geometric sequence, and the common ratio in this case would end up being a value of 1/2. So now that I know it's a geometric sequence and the ratio is 1/2, I can write the recursive formula. So how do you do that? You state the first term. So in this case, my first term, u sub 1, would be equal to 5/2 because that's the first term in the sequence. And to find the nth term, that would be equal to my common ratio r, so 1/2, times u to the n minus 1, so times the previous term. And of course, we also have to state that in this case, n has to be greater than or equal to 2. So this right here would be my recursive formula for the given sequence. So then the next problem says we want to find the common ratio of the geometric sequence with u sub 1 is equal to 2 and u sub 2 is equal to 8. List the first 5 terms of the sequence and write the sequence as a recursive function. So if we start our sequence, we know that already our first term is 2 and our second term is 8, and we also want to find the next 3 terms of the sequence because it says list the first 5 terms. So first things first, in order to write this as a recursive function, we have to figure out what our common ratio is. We already have our first term, which is 2, so that's kind of nice. So to find my common ratio r, I know that r is equal to my 8 divided by 2, so my second term divided by my first term, which in this case ends up being 4. So now that I have that, I can go ahead and figure out what my recursive formula is going to be. So for my recursive formula, so the recursive formula would be u sub 1 is equal to 2 and u sub n is equal to my common ratio 4 times the previous term u to the sub n minus 1 for all n greater than or equal to 2. So now if I want to find the first 5 terms, we already know the first 2, 2 and 8, I would just plug them into this formula. So to find the third term then, I would do 4 times the 8 because the 8 is my previous term. So 4 times 8 gives me 32. And then I would multiply again that by 4. So 32 times 4 is 128. And then 512. So the next thing that we're going to talk about now is we're going to discuss how to find the explicit form of a geometric sequence. So the explicit form for a geometric sequence, remember, means that you can just plug in whatever the term number is, and then you should be able to go ahead and easily find what the that term is equal to in the sequence that you have. Whereas recursive, you have to know the previous term in order to find the next term that you're looking for. So if we look at the form of this, you notice that you have u sub n is equal to your first term and then r to the n minus 1 power. So in this case, what you need to know is your first term, and you need to know what your common ratio is. And of course, for this, your common ratio could not be a value of 0, otherwise it would not work. So let's go back up to the previous problem and see if we can write the explicit equation for this. So the explicit equation, we already know our first term, so to get to the nth term, u sub n, you would be equal to your first term, which is 2, times your common ratio 4 raised to the n minus 1 power. And in this case, n just has to be greater than or equal to 1 because we already stated what our first term is in the actual sequence. And this formula is nice if I had to find, let's say, the 100th term, because all I would need to do is plug 100 in for n, and I could easily figure out what the value is equal to. Whereas in the recursive formula, I would have to find every single term up to the 100th term, so all 99 terms, and then I can find what the 100th term is equal to. So let's go ahead and look at the next example. So for this next example, it says, write the explicit form of a geometric sequence where the first two terms are 2 and negative 2/5, and find the first 5 terms of the sequence. So when I start writing the sequence, I know my first term is 2, my next term is negative 2/5, and I want to find the next 3 terms after that for the first 5. So first things first, I need to find my common ratio, r. So I take negative 2/5 divided by 2, and I get r is equal to a value of negative 1/5. So let's go ahead and write both the explicit and recursive formula. We'll start with the explicit first. So for the explicit, to get to the nth term, u sub n would be equal to my first term, which is 2, times my common ratio, negative 1/5, raised to the n minus 1 power, where n would have to be greater than or equal to 1. So if I wanted to find my third term, I would plug 3 in for n, so u sub 3 would be equal to 2 to the negative 1/5, all raised to the, now you plug 3 in for n, so 3 minus 1 power. So when I do this, I get u sub 3 is equal to 2 times negative 1/5 to the second power. So when I plug this into my calculator, I would end up with a value of 2 over 25. So that is the third term in my sequence. So 2 over 25. And then of course I could repeat this for the fourth and fifth term. You would end up with negative 2 over 125, and the fifth term is 2 over 625, and then of course I could keep on going. So now I want to go ahead and figure out our write a form's recursive form, even though it didn't ask for that, just so that we can see. So the recursive form would be this. So u sub 1 would be equal to 2, and to get to the nth term, you would take your common ratio, negative 1/5, times your previous term, so u to the sub n minus 1, for all n greater than or equal to 2. So, and of course, to use a recursive formula, you'd have to find all the preceding terms up to the term that you wanted to find, and then you can find your answer.